a to the power x, 2 to the power x, how to differentiate this, or 5 to the power x, anything like this. So let we consider a to the power x, say y equals to a to the power x. Then if we apply ln on the both side, logarithm, exponential base logarithm on the both side, then you can write it ln y equals to ln of a to the power x. So then the terms becomes ln y equals to x ln a. That is the term. Now the way we did the implicit differentiation, if you don't know the implicit differentiation, please click on the I button on the right top to see the implicit differentiation. If we differentiate here with respect to x, then you can write here 1 by y dy by dx equals to, on the right side it becomes only ln a, because ln a is a constant and here x is a single term, so it gives us ln a. Then you can write it dy by dx equals to y ln a. Y is actually y we considered here a to the power x, so it turns to a to the power x ln a. This is our differentiation of ax. So similarly, if you write there, if it is written there 2 to the power x, then if I ask the differentiate of 2 to the power x, definitely it would be 2 to the power x ln 2. We can write from there because we already have proved it. D by dx of, similarly you can write it 5x, it definitely would be 5x ln 5. We know even e to the power x it is written there, then d by dx of ex equals to ex ln e. It becomes e to the power x because we know ln e equals to 1. This is the value of the ln e. So if it is written with a, say, negative power, 3 to the power negative x, what is the differentiation of that? D by dx of, so definitely it would be 3 to the power minus x ln 3 into minus 1. If we differentiate x, we got from there minus 3 to the power minus x ln 3. This is our differentiation of that part. So that is the total working. Say if we consider another term, say if written x to the power x, what is the differentiation of x to the power x? We're going to prove it towards the differentiation of x to the power x. Let you consider x to the power x as a y like before. Let consider y equals to x to the power x. Now we are going to apply logarithm, exponential base logarithm on the both side, which is ln y. Then you can write on the right side ln x to the power x. Then on the left side it is ln y equals to, and the right side it is definitely x ln x. Now we are going to apply differentiation with respect to x on the both side. Then from the left it is written here ln y, then it should be 1 by y dy by dx on the left side, because we know if we differentiate something with the ln y but it is written here y, then it would be d by dy of ln y into dy by dx. So d by dy by ln y is definitely 1 by y, then dy by dx. So I have lot of actually differentiation about the implicit function. Please click on the I button, see the differentiation relevant with the implicit function. That function is called the implicit. So on the right side, two functions are there, x and another one is the ln x. We needed to apply the differentiation of the product rule. Let me apply, then ln x, definitely on the right side it would be d by dx of x. So we are going to break down now it 1 by y dy by dx equals to, let me differentiate x into ln x. If we differentiate, we got from there 1 by x, then ln x, differentiation of x is 1, so it turns to x, and x we can cut out, x plus ln x on the right side we got. So finally we can write the expression dy by dx equals to y into x plus ln x. So we can write it x to the power x plus ln x is answer of this question. I did a big mistake, let me correct it. So it would not be x, so we needed to write here 1 plus ln x. Let me correct everything from there. Anyway, I noticed it before the my video ended. So 1 plus ln x, definitely it would be ln x 1 plus ln x. So this is our answer of this question. Hope you understood.